When the members of the design team have completed their design of the structural, electrical, plumbing, and HVAC systems, they can share their models so that the changes they've made can be reviewed and coordinated. We'll start by linking the Revit structure model back into the architectural model so we can find the changes and act upon them. Let's open the Revit architectural application and open the architectural model that was linked to the Revit structural models in the previous lesson. Then we'll open the 3D with section box view so we can see inside the building. To see the elements added or changed by the other discipline, we'll link the Revit structural model back into this project. Let's link it, being careful to choose the Auto Origin to Origin Position option to make sure the coordinate systems are aligned. The linked structural model appears in our Revit Architecture Host project, and we can see the structural elements from the linked model overlaid in our 3D view. Let's select the section box and move the face forward so we can see the retaining walls, wall foundations, and foundation slab at the lower level. Then we'll move the section box back again to cut a section and zoom in so we can see how the structural floors and framing elements in the linked model fit together with the architectural walls and elements in the Revit Architecture Host model. Now that we've linked the structural model back into the architectural model, we can find the changes that were made to the structural model to the shared model elements, the pieces that were copied into the structural model using the Copy Monitor tool. Switch to the Collaborate tab and open the Coordination Review tool, choosing the Select Link option. Then select the linked structural model in the 3D view. Coordination Review report appears and displays a list of the shared elements that were changed in the linked model. We can expand each message in the list to see the specific elements that were changed. In this first message, a floor element was deleted. We can select the elements in the list, and in the 3D view, we can see that it's the generic 12-inch floor at the lower level in the architectural model. This element was deleted and replaced in the structural model with a foundation slab. We can choose an action to resolve each of these changes. In this case, we can do nothing, in which we would leave the floor in the architectural model in place, or delete the floor element to match the change in the linked structural model. We'll choose to delete that element, then click Accept to make the change. Next, we'll look at the floors whose thickness was changed and expand one of the messages. When we click on an element in the list, we can see that it's the floor at level 3, which was changed from a generic 12-inch floor to a plywood floor in the structural model. In this case, we'll choose to do nothing at this point. We'll go back and delete these floors in the architectural model and use the floors defined in the linked structural model after we review and resolve a few other changes. The next few messages are similar changes that were made to the floors at level 4, level 1, and lastly at level 2. We'll choose to do nothing as the action for all these cases. Let's continue acting on the changes reported in the Coordination Review dialog. Under the Grid section of the list, we can see the changes that were made to the positions of Grid C are reported. Let's open the Level 1 floor plan view and resize the Coordination Review dialog to move it out of the way. Then we can click on the message in the Coordination Review dialog, and the related elements are highlighted in the plan view. For Grid C, let's choose to modify Grid C, which will move the grid in our host model to match the position in the linked structural model. Then we can do the same for Grid B, also moving the grid in the host model to match the linked structural model. Then we click Accept, and the changes are made and appear in the floor plan view. The last group of messages is related to the changes made to the retaining walls at the lower level. Let's open the lower level floor plan view and select the wall in the host project. Then we can click the Show button to highlight that wall in the view. As we expand the other messages, each time we click the Show button, Plan View pans and zooms to highlight and show us the selected element. Let's continue with the Coordination Review messages and look at those items that need to be deleted in the host model because they will be replaced by elements in the linked structural model. Coordination Review shows both the changed element in the linked model and the original element in the host model. If we select an item in the list, it highlights it in the drawing area. Let's close the Coordination Review and delete those items. We'll select each of the floors in the architectural model, and as we delete them, the structural floor in the linked model remains. We can also delete the retaining walls in the architectural model, and the elements that replace them remain. We can repeat these steps for all of the shared items that are now controlled in the structural model. Now let's take a look at the integrated model, showing elements both from the host model and the linked structural model with all the changes resolved. We can open the 3D with section box view to see the entire model, including all the architectural elements. Or switch to the 3D building skeleton to focus on the structural framing elements. Note that the stairs, which are defined in the host architectural model, are also visible in this view. Going back to the 3D with section box view, let's use the VG shortcut to open the Visibility Graphics overrides and switch to the Revit Link tab to turn off the visibility of the linked model and hide the structural elements. Then open the Visibility Graphics overrides again to turn on the linked model to show the structural frame and foundation elements.